Okay, so this is the example 2 of the calculations that falls under resistance and resistivity. Okay, so a piece of wire of cross-sectional area 2 millimeter square has a resistance of 300 ohms. Find A, the resistance of a wire of the same length and material if the cross-sectional area is 5 millimeter square. And then B, the cross-sectional area of a wire of the same length and material of resistance 750 ohms. A piece of wire of cross-sectional area 2 millimeter square has a resistance of 300 ohms. Find A, the resistance of a wire of the same length and material if the cross-sectional area is 5 millimeter square. B, the cross-sectional area of a wire of the same length and material of resistance 750 ohms. Okay, so you are once again welcome to my channel. Before we move on with the solution, please make sure you subscribe and you share the videos. Solution. So we know that R is proportional to L and inversely proportional to A. R being our resistance, proportional to L, that is the length, and then inversely proportional to A, which is the cross-sectional area. Okay, so here we assume the length to be 1. Okay, so by substituting the values, we have 300, which is our resistance, proportional to 1 over 2, 1 being the length and then 2 being our cross-sectional area. I hope you are following it. So by applying the coefficient of proportionality, we have 300 equals K, that is the coefficient of proportionality, multiplying 1 over 2. I hope you understand. So to make K the subject, we have K equals 300 multiplying 2. And when you multiply 300 by 2, we are going to get what? 600. So now the coefficient of proportionality, which is K, is what? 600. Okay, so now that we have calculated for the coefficient of proportionality, which is K, let's solve question A. And question A says we should find the resistance of a wire of the same length and material if the cross-sectional area is what? 5 millimeter squared. So A, when the cross-sectional area A is 5 millimeter squared, then our resistance R is going to be what? K multiplying 1 over 5, that is the length over the cross-sectional area. K, which is the coefficient of proportionality, multiplying 1, that is the length over the cross-sectional area. So we have K to be what? 600 multiplying 1 over 5, and that is going to give us what? 120 ohms. Okay, so the resistance is going to be 120 ohms. That is when the cross-sectional area is what? 5 millimeter squared. I hope you're following it. So let's move on to the B. The B says we should find the cross-sectional area of a piece of wire of the same length and material when the resistance is what? 750 ohms. So B, when the resistance is 750 ohms, we know that 750, that is the resistance, is equal to what? K 1 over the cross-sectional area 1 over A. Okay, so we are to find A, which is the cross-sectional area. 750 is the resistance, K is the coefficient of proportionality, 1 is the length, and then A is the cross-sectional area. So we have to find what? The cross-sectional area, because we already know K to be what? 600. Okay, alright. So the cross-sectional area A is equal to what? K over 750. That is to make what? A the subject. Okay, so K is what? 600, and then the resistance is what? 750. So when you divide 600 by 750, we are going to get what? 0.8 millimeter square. So our cross-sectional area is what? 0.8 millimeter square. I hope you understand. So from the question, A says we should find the resistance of a wire of the same length and material if the cross-sectional area is what? 5 millimeter square. So that is what we calculated here. So the resistance when cross-sectional area A is what? 5 millimeter square is what? 120 ohms. And B says we should find the cross-sectional area of a wire of the same length and material of resistance when the resistance is what? 750 ohms. So that is the solution that we have here. So when the resistance is 750 ohms, our cross-sectional area, which is A, is what? 0.8 millimeter square. Thanks so much for watching.